Dear students, today we are going to discuss on Hamming code for error detection and correction. In the previous class we have seen how to generate the Hamming code. So if there is an error occurred during the transmission, it can be detected and we can even correct the error by using the Hamming codes. Today we will see how the steps or how the procedure is for detection as well as the correction. So there are many chances for a error to be happen, maybe because of noise or due to interference. So there are many reasons for the error to be introduced into the system. Okay. So what will happen? There will be difference of the message that is transmitted from the transmitter and that is received in the receiver. By using Hamming code, we can detect the error as well as correct. One bit of error can be corrected by using Hamming code. It's a block code. It can detect the errors as well as it can correct the errors. We will see one example. So we are having a 7-bit code that is received. We have to check whether the received code is correct or incorrect. If it is incorrect, we have to correct it. That's the question. So we know that 7-bit code actually 4 bits are the messages and 3 bits are the parity. So the first 2 bits P1, P2 and the fourth bit is P4. So 3 parity bits I have given in red color and other bits are the bit number 3, 5, 6, 7. They are the message. So 0, 0, 1, 1 is the message, 1, 0, 1 is the parity. So what we have to do is we have to check whether the parity bits are correct as per the received message. So while checking we can see that parity bit P1, so the parity bit P1 as per the odd parity, in the question itself it is given the system is following odd parity. So as per the odd parity, P1 should be 0, but here in the message that is received, P1 is 1. So there is an error in P1. Similarly, for P2 is concerned, P2 is 1 in the received message, but P2 is 0, but P2 should be 1 if we are looking into the message. So there is an error in P2 also. For P4 is concerned, the third parity at the fourth position, that is P4, the given message is having a parity 1 and when we are checking the message bit that is received, it is also 1. So there is no error in P4, that is given in a green color. So we have 3 parity bits, out of which 2 are in error. P1 and P2 is error and P4 is having no error. Okay. So what you have to do is, now you have to find the position of the error, where the error is happened. You are having the message, okay, only 1 bit error can be detected by using this. So the position of error can be found out by writing the parity in order. For example, we are having 3 parity bits, that is P4, P2 and P1. So the MSB is P4. So you have to write like this: P4, P2, P1. And if there is no error, please listen carefully. For a parity bit, if there is no error, don't look into odd or even, whatever it is. You just check whether there is an error happened or not for P4. We have seen that there is no error for P4, so you have to keep a 0 there. But in P2 and P1 there are errors, isn't it? So you have to keep 1 under P2 and 1 under P1. That is, if there is no error for any parity, keep a 0. If there is an error, you have to put 1. So here the bit becomes now 0, 1, 1. This 0, 1, 1 is nothing but it is the decimal corresponds to 3. This binary 0, 1, 1 corresponds to 3. So there is an error in the position 3. You can see that 1, 0, 0 is the third position, it is 0. So if there is an error in 0 means, or the third position means, then the correct one is the inverse of 0, or we can say in binary it is nothing but 1. So the actual message with is 101111, that is in the third position. We have changed 0 to 1 because the error happened at the third position. This is how we can find the position of the error and we can correct it. One more example also given. Okay, here again a 7-bit, and its even parity is the scheme that is followed. Here also you can see, first you have to write the parity bits as such: P1, this is P2, then the fourth position, it is P4. Then you have to check for the parity bits where it is correct or not. So while checking, we can see that P1 is exactly same in the received message, and the parity bit is also same, so no error in P1. But you can see there is error in P2 as well as P4. So what you have to do is you have to write under P4 1, under P2 1, and under P1 it is 0, because if there is an error in the parity, you have to write 1. If there is no error, you have to write 0. In this case, don't look into which parity or like that. Only for checking the parity and checking for the error, you have to look into the parity status. But while writing in order to find the position, what you have to do is simply write 1 if there is an error occurred in a particular parity bit, and you have to write 0 if there is no error occurred. So we got the parity P4, P2, P1 as 110, which is equivalent to the position number 6. So here in the received message, position number 6, it is 1, but you have to correct it. So replace 1 by 0, you will be getting the actual message, the original message. It is 1010101. So this is how you can detect the error as well as you can correct the error. So the corrected message is given here. That's all.